My name is Steve Ashburn. I'm president of Private Fund Corporation. I'm going to demonstrate how to use the semen detection kit that my company has developed. This test kit has 4 things in it: acid phosphatase test strips in this canister right here, prostate specific antigen test strips in these sealed individual pouches, a dropper, and an instruction sheet which isn't shown. You're expected to provide a source of distilled or deionized water, a coffee cup, and gloves if you wish to use them. What we're going to do now is demonstrate how to analyze an actual garment with a suspected stain on it. Here we have the garment right here. What you first do is you pull out the garment and you look at it and identify the stain so we can look at the stain directly. Now, semen has over 900 identified proteins. This test kit tests for 2 of them, acid phosphatase and prostate specific antigen. What I'm going to do is demonstrate how to test for acid phosphatase first, and then I'll do the test for prostate specific antigen. Now the procedure is to place 5 to 10 drops of water on the suspected area, in other words, the crotch. Now sometimes it may take more than 10 drops of water depending on the stain. Sometimes vaginal discharge can be heavy, thick, and it may take more than 10 drops. So you'll just have to look at the stain and estimate how much water it will take to dissolve the substance inside the fabric. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I'm going to let that soak in for about 60 seconds to give the material inside the fabric time to dissolve. And then we're going to do a test, an acid phosphatase test. These are what the test strips look like. Now, since we don't know where this garment came from, we want to use gloves. Like this. This method for detecting semen was first described by Babson in 1959. It consists of, or it relies upon, catalytic hydrolysis of naphthyl phosphate by an enzyme found in semen, acid phosphatase, which catalyzes the hydrolysis of naphthyl phosphate to naphthol, which then reacts with the diazonium salt to form an intensely colored blue dyestuff. Dyestuff chemistry itself was discovered in the 1700s by Perkin, and it consists of a couple of major steps. The first step being conversion of an arylamine to a diazonium salt, and the second step being coupling of that diazonium salt with an aryl alcohol or arylamine. This test strip has in it 2 components that we use in dyestuff synthesis. One is a diazonium salt, the other is a precursor to an aryl alcohol, namely naphthyl phosphate. When this test strip comes into contact with semen, the acid phosphatase in the semen catalyzes the hydrolysis of the naphthyl phosphate to naphthyl alcohol, which then immediately reacts with the diazonium salt to form an intensely colored blue dyestuff. Hence, a positive test would be dark blue or purple. Now the procedure is to place the test strip on the stain for about 5 seconds, pull it off, and read it within 60 seconds. Vaginal discharge does have a little bit of acid phosphatase in it, so it's important to read the test within 60 seconds to avoid a false positive test. So here we go. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. Now that's a positive test. It turned blue almost immediately. This is a strongly positive test and a presumptive test for semen. What I'm going to do now is demonstrate yet another technique, because there's a possibility that this purple dye stuff may transfer to the fabric. So let's just get it wet just a little bit more for the purposes of this demonstration. The second technique I'm going to describe uses a Q-tip to transfer material from the garment to the Q-tip, like this. You wrap the underwear around the Q-tip, transferring as much material as you can to the Q-tip. We're going to press the crotch around the Q-tip, trying to absorb as much as we possibly can. Now, this technique is going to avoid leaving any dye stuff on the underwear so that whoever wears the underwear won't become suspicious that you've been testing it. Now, place the Q-tip on the test strip for 10 seconds. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000. That's a positive test. This gives a little bit better defined spot than placing the strip directly on the underwear, but the technique is up to you. Actually, it's a little simpler just to put the strip directly on the underwear. Now, this is a presumptive test for semen. Doesn't mean it is semen, doesn't prove it is. In order to do that, we have to follow this test up with a second test. And this test is for prostate-specific antigen. These test strips come in these pouches right here. The procedure is to put 15 mils of water into a coffee cup, like this. Five, 10, 15. Now take the garment, turn it inside out so that the inside of the crotch faces outwards. Grab the crotch between your thumb and forefinger and place the underwear in the water inside the coffee cup and let the water soak in to the underwear and then squeeze it out. Soak in, squeeze out. Soak in, squeeze out. What we're doing is extracting all that we can that's water soluble from the stain that's on the underwear. Do this about 15 or 20 times. And when you finish doing it, wring out the underwear as well as you can into the coffee cup like this. There. Now this preserves the underwear so that you can wash it again and wear it. Some people punch holes in underwear and take out samples for analysis, but that's really not necessary. All you have to do is extract it into a coffee cup. Now what we're going to do is put a PSA test strip inside the coffee cup. Take a pouch, open it, put it out. Inside this pouch you'll find a PSA test strip and a desiccant packet. The procedure is simply to take the test strip and put it in the coffee cup. What I like to do is tilt the cup slightly and put this desiccant packet under it as a convenient way of moving the water to one side so it'll be deep enough. Take the test strip and place it in the cup. Now you're supposed to wait for 10 minutes officially, take it out, place it on a dry surface, wait 10 more minutes before reading it. If you see 2 red lines, it's a positive test. If you see 1 red line, it's a negative test. Now in the meantime, while this is developing, I want to say a few words about statistics. Statistically, 50% of men who think their wives are cheating on them are correct. The other 50% are wrong. You need to ask yourself a question. Why am I suspicious? Perhaps part of the reason could be difficulties in communication. Some women are inconsistent in the way that they communicate, both verbally and non-verbally. They'll say one thing one day, the next day they'll mean something completely different. And this may be enough to make you suspicious, especially if your habit is to communicate objectively. For example, let's suppose that your wife comes home and she's suddenly aloof, distant, doesn't want to touch you, doesn't want you to touch her, has strange vaginal discharge, goes out and buys herself all new flashy underwear, starts going to work early, starts coming home from work late, and starts going on out-of-town business trips with a male colleague. Does this mean that she's committing infidelity? No, it doesn't. In fact, this can be typical female behavior in some women. Remember, infidelity is a physical act, and physical acts always have physical evidence. That's why we have a semen detection kit, so that you can get physical evidence. You cannot prove infidelity by subtle nuances in communication or behavior. Now, there are other means that you can use to gather physical evidence besides the semen detection kit. You can monitor her internet surfing activity, her email, her instant messaging, her cell phone call logs, and you can use GPS to monitor where she's going, or place covert audio or video devices to find out what she's saying and doing while you're not there. If you do all of these things and you don't find any evidence, then she's probably not guilty, and you should give her the benefit of the doubt. If she is doing something, then you'll probably find out about it fairly quickly. There have been a couple of statistical studies measuring the rate of infidelity in married women in the United States. One was published in 1994 by the University of Chicago, the other in 2002 by the Centers for Disease Control. The 1994 study found that approximately 14% of women and 22% of married men have an affair sometime in their marriage. But the flip side of this is that 86% of them do not have an affair anytime in their marriage. They remain completely faithful to their husbands as long as they live. Probably you're in that 86%. But there's a chance that you're not, and that's why we have a semen detection kit. The 2002 CDC study showed that approximately 4% of married women and 4% of married men had more than one sexual partner in the previous 12 months. This indicates that the rate of infidelity is probably in the low percentages, say 3% or 4% per year. But the flip side of this is that 96% or 97% of married women are not committing adultery every year. And you're probably in that 96 or 97%. But there's a chance that you're not. That's why we have a semen detection kit. Well, it looks like we have a positive test. What we have here are two red lines on the test strip. The top red line is the control line. It always comes on no matter if the test is positive or negative. This line indicates that the test is successful, whether negative or positive. The bottom line is the test line. What it indicates is the presence of prostate-specific antigen. Now, this test strip works by having 3 different antibodies. One antibody is an antibody to PSA. The second is an anti-human antibody, and the third is an anti-mouse antibody. When you dip the test strip in water, the anti-PSA antibody is at the bottom. It complexes with PSA. That antibody is gold labeled and appears red. That antibody moves up the strip until it comes to the test region, where you have anti-human antibody bound to that region. If there's PSA there, that antibody complex binds to it and turns red. If there's no PSA there, it's blank. The anti-PSA antibody, gold labeled, continues moving up the strip until it reaches the control region, where you have an anti-mouse antibody binding to it, and this also turns red. Now, this control region is calibrated for a PSA concentration of 4 nanograms per mil. At that concentration, the specificity of this test is 100%. In other words, the probability that this is PSA is 100%. So by inference, the probability is 100% that there is semen on the test garment. If the test strip region is less intense than the control region, then there's less than a 100% probability that this is PSA. According to the literature, if you can just barely see the test line, there's a 90% probability that what you're looking at is PSA and therefore semen. In case of a weak test, where you have a weak PSA test and a weak acid phosphatase test, the combination of both tests used together gives the investigator a more certain conclusion that what he's looking at is semen than either test taken by itself. And that's one reason why we include two kinds of test strips in this kit. So in the case of a weak test, you can have a more certain conclusion that the garment does in fact contain semen. First test, AP, is a presumptive test. The second test, PSA, is a confirmatory test. Therefore, the semen detection kit that we have here is a two-step procedure of presumption and then confirmation that the material on the garment is in fact semen. This concludes our demonstration of the InSite Semen Detection Kit.